Folks, hello and welcome to week 8. This is the first of two parts of your practical exam to finish up the course. And this is related to our second look at inferential statistics techniques, this one being hypothesis testing. What I have on the screen here is an overview of the project itself. And what I wanted to do, I'm going to actually do a couple videos for you here. I'm going to do this one for week 8, then I'll do another one next week, which is going to show a little bit more of the computational work that you're going to be doing. What I want to do is I want to get through the options that you have for completing the practical exam, and then look at the questions that you have to answer for this week. What I have done, and as you're going to see, the data sets that you are going to be given are related to aircraft altimeters. I'm going to use some fictitious baseball data. So if you like baseball, today's your day. We'll talk a little bit about baseball along with some altimeter information as well. So let's see, just to talk through this a bit, it says you will evaluate an aircraft altimeter data sample from different companies to determine if there are any differences in error. You have the following three options for running the appropriate t-test. So what we want to do again is I want to talk through these options real quick and make sure that we distinguish between all three and then realize what sort of statistical test we're actually going to run. So the first option here says compare one brand against a hypothesized mean to determine if the brand is statistically different than the assumed norm. In this case, you would have to cite where the hypothesized population mean came from. So that's one. Option 2 says compare one brand against another to see if there are significant differences between them. So notice right away the difference between option 1 is option 2. Option 1 is simply one company against an assumed normal or assumed norm for an error rate in altimeters. The second option is comparing effectively brand X against brand Y. And then option 3 says compare either altimeter area of Acme or brand X before adjustment and calibration and after adjustment and calibration to see if there are any differences in the means, in the mean performance. So what we're saying here is we're going to just look at one brand. We're going to measure the error rate for whatever the number of altimeters that we have in the sample size. We're going to make some adjustments, and then we're going to recalibrate them to see what has happened to the error. So option 1 and option 3 are similar in some degree. Option 1 is simply comparing a data set against a hypothesized mean. Option 3 takes one of those companies pre-adjustment and then compares it to post-adjustment. And then option 2 compares one company to the other. So make sure that before you get started on this that you wrap your head around each one of these, because statistically speaking, the tests are going to be a bit different. And so if you look right below option 1, option 2, option 3, these are the tests that would relate to option 1, 2, and 3 respectively. So a one sample t-test, a two sample t-test, and a paired t-test would be the options. So that's what you're going to be. That's what you're going to be presented. Whichever option you choose is up to you. What I want to make sure in the next slide is we talk through this just a bit, talk through the questions, just to make sure that you're clear on what I'm looking for this week, and to make sure that you are absolutely positively set up to complete the last half of this next week. So let me see if I can get to my next slide here. So these are the questions in the statement of the problem in Module 8. It says there are 4 questions that you need to answer this week. And this is all that I want you to answer this week. It says the first one is describe what you are comparing. State your hypothesis in a sentence. This can be as simple as the altimeter error for brand whatever is higher than brand whatever. We'll talk about these and the options that you have for that as well. It says indicate the appropriate t-test that you will use to evaluate your hypothesis, and then state the alpha level. And remember, well, I won't say remember because if you haven't gone through the reading yet, effectively what alpha is going to represent is the probability of rejecting the null hypothesis. And so we'll talk a bit, but alpha has a bit of a difference here. I apologize for that, folks. Has a bit of a different application here than it did in confidence intervals. So we'll be very careful about alpha, because this will also represent the probability of a mistake when we assess our statistics to judge the null hypothesis. So as I said, I've got some fictitious baseball data here. I'll explain what it is in just a bit. But this option 1, option 2, option 3, these data sets correlate with option 1, option 2, option 3. Let me just go back here and remind you of what you can choose for your project setup, where you compare one brand against a hypothesized mean. You can compare one brand against another mean, or compare one brand to another, and then you can compare within a single brand pre-adjustment to post-adjustment to see if there's any difference, statistical difference in the readings at that point. So just very quickly, what I've got here is, so what I'm going to assume is I've picked all 30 baseball teams from both American and National League, and I've taken what you see here is the batting averages for each of the second basemen. And so you can go down through this list. You got all sorts of all 30 averages. And then what I'm going to, or what I would do in this particular option is I have a hypothesized mean of a batting average for a second baseman at 255. And so the description here for this case would be that I'm comparing from 2022 the batting averages from all 30 professional baseball team second baseman against a hypothesized mean, which has been calculated for the last, let's say, last 30 years. And so that is a good value, and certainly could be done in a case like this. What I would be looking for here, so here's another thing that we've got to be very careful about this week when we set up the hypothesis statements here in Part B. There's a couple of different things I could say here. There's actually 3 things that I could say here. I could say that that last year that there is no statistical difference in the average batting averages against the hypothesized mean. I could say that last year the batting averages were greater than the hypothesized mean, or the batting averages were less than the hypothesized mean. And it's very important this week that you make it clear what it is that you are setting up as your hypothesis, because next week when you get started, what we're going to do, and we're not going to do it this week, but we will next week, we're going to set up the hypotheses using statistical notation. And that being, we're going to set up a null hypothesis, and the null hypothesis will represent what we believe to be true, and the alternative hypothesis, and that is what we will test. In this case, this would be a 1 sample t-test. And then also in the video next week, I will show you, briefly show you what that looks like in Excel. So option 2, remember option 2 was comparing effectively one company altimeter to another company altimeter. So what I did is I just broke these up, and I'm going to say that what you see on the left is all the players from the American League, and what you see on the right is all the players from the National League. It just so happens here that the number of teams in the American League is the same as the number in the National League. This is not to say that when you run a 2 sample t-test that you have to have the same number of observations in each data set. It just happens to work out that way. But let me just make the point here, because you're going to see when you go through the reading and do your homework, you'll see a lot of 2 sample t-tests where the sample sizes are different. But in this case, again, just looking at the hypothesis, again, there are 3 ways that I could present this. I could say that there is no difference in the averages between the American League and National League. I could say that the American League is greater than the National League, the batting average, or I could say alternatively that the National League batting average on average is greater than the American League. But again, just make sure that you're very clear this week when you state your hypothesis exactly what it is you want to test. Because next week, when I look at your work from week 9, that's going to be the first thing I do is compare what you said in writing to the way that you have set up your hypotheses, because that is how you will judge the statistical outcome when you get to that point. So in this case, indicate the appropriate t-test. So this would be a 2-sample t-test. And then finally, option 3, remember this was the one where the altimeter is assessed prior to calibration. Then there is some calibration to the altimeter, and then it is recalibrated to see if the error has improved. So what I have for my option 3 is I'm going to say that from this group last year of the 30 second basemen, that 14 of them were free agents, which means they were at a point in their career where they could effectively go sell their services to another team. And so what I have in the pre-FA column, the pre-free agency column, is their batting average, we'll say for last year. And we'll just assume for the sake of what we're trying to convey here that that this is their batting average. Let's say that the season's done. The season's got about 10 more games. But we'll say that this is the batting average after their free agency. And sometimes people believe that after a player signs a big contract that their performance will drop the following year. That's not important for today. But what I want to make sure that we're clear about in option 3 is that when you are doing what we call a paired t-test, that the subjects that you are comparing are the same in the pre-measurement and the post-measurement. So this absolutely would have to have the same sample size if we were going to run what's called a paired t-test. And so again, when I look next week, if you have chosen option 3, what you could say is that that there is no change in altimeter measurement or altimeter error after the calibration. You could say that the error has decreased from, let's say, pre-adjustment to post-adjustment. I don't think we would want to hypothesize that it had gotten worse. But if you wanted to say that, or if you wanted to hypothesize that, you certainly could. But again, just make sure that your statement is very clear this week based on the option that you've chosen and what it is you want to test. So what we haven't stated, and I think what we can state for all 3 options, is the alpha value here. And remember, as we kind of go through this idea of hypothesis testing during weeks 8 and 9, you'll get a better feel for what alpha is. But typically, we want to make alpha a small value because it will represent the probability of making a mistake or making the wrong assessment about what it is that we have chosen to say is the current state of whether it be option 1, option 2, or option 3. So what I'm recommending is that for each of the tests, regardless of the test that you choose, that you state your alpha level at 0.05. I wouldn't go any higher than 0.05. If you wanted to go to 0.01, that is 5 times less probability of making an error in assessing the null hypothesis. That's a pretty stringent measure for alpha. So I think 0.05 is good, but if you want to go that low, that's sort of the range, 0.01 to 0.05. So I hope this helps everybody get set up for next week. These are the only 4 questions that I want you to address this week. I just want to make sure that everybody understands what it is we're looking for. And again, this is what will set you up for week 9. So if you have any questions, let me know. And I hope this is helpful. And I'll look forward to seeing your work towards the end of the week. Thanks.